Sweet. Okay, I should be good. Nice. All right. Hope everybody sees that. Um, cool. Okay. And I also started recording lectures, so we can probably just go ahead and upload that, and that'll be all good for anybody trying to watch the lecture later. All right. That being said, I'm all good to get started. So yes, welcome to the first online lecture for 389E, and today we're just gonna get through sequential programming. And these constructs called latches and flip-flops. So basically just an extension of like memory stuff that we were doing before. I tossed in a little recap for us since it's been like 2 weeks since we've done anything in class. But first, like a few announcements. So real quick, yes, so logistics stuff, class will be online for the rest of spring 2020. This means that lecture will now be held, I guess now, every Friday on Discord. And again, if you really can't make it, lecture will be recorded and uploaded to an accessible location. We're thinking of probably, YouTube, or we could probably do like Panopto or something. We'll probably put a poll up and figure out the best place to dump it on there. And additionally, Ashwath has figured out how to get our worlds uploaded onto the CS Submit server. He built a little web app for that. So now all you'll be able to do is run a test from your file, upload the zip file to the submit server, and you should be all good there. So I'll let him talk a little bit more about that, but that is what we've got. So I guess no more manual grading, so that's exciting. Okay. And just a little recap of the online resources that we've got since we're all moving online now. So real quick, Piazza is a place to ask questions and get answers. Usually Ashwath will be posting here about like posting project like releases and solutions. So be sure to check, whenever you can. Elms is where you want to look at to see your current grade in the class. So that's, if you want to see how you're doing, you just check Elms basically. And now the CS Submit server is where you'll be turning in all your projects. And Ashwath's web app is how you'll be like getting that done. So again, he'll talk about that a little later. The course website is actually to be updated. I'll probably finish that by end of day today. But this will be where we'll be like mooshing everything for each week and dumping all the resources and all that. Right now, I know there's like a fully working project spec for project 4 on Piazza. For some reason, the link that I have on the course website doesn't work. I probably just missed a character or something somewhere, so I'll go ahead and fix that. And of course, if you want to reach us, just go ahead and email us or reach out to us, and we will be available. Cool. Yeah, another thing about like online lecture, again, like Ashwath said, the lecture questions channel, if you want to say something, like if you want to ask a question or something, just go ahead and type in there. I think you all should have access to say stuff in there. And either of us can go ahead and address it. Cool. Also, one more logistical thing. I'm not sure if I can get Ashwath's audio in. Oh no, for the recording. So I'll go ahead and. Oh, does it do that? Oh, okay. Sweet, that's amazing.
Okay.
Oh shit, yeah, it does. Okay, yeah,
Yeah,
you're
we'll
fine.
see. Okay.
Yeah, okay, cool. It's okay. It says it's inputting your audio as well, so let's hope that works.
Okay. I'm probably not going to say anything that's not in like Piazza or Discord at some point anyway. So.
Sweet. Okay. Awesome. That's cool. All right. Okay, so Discord. Yes, the Discord is up. Since you're watching lecture right now, it sounds like you've had no trouble joining it. Yeah, if you have any issues getting Discord set up, feel free to contact either of us for help. Everything should be fully functional, but again, feel free to reach out. Ashwath, is there anything you wanted to say about Discord?
It's definitely the easiest way to reach me. I'm always on my computer, so if you send me a message on Discord or post anything here, I'll probably get back to you like within 5 minutes. Which a lot of people have already used. Like there was a bug yesterday with Project 4 solutions, and it got fixed in like 20 minutes, as opposed to like a day if you were to post that shit on Piazza. So definitely for me, Discord's the easiest. I don't know about Aki, but yeah, Discord is definitely my preferred method of communication.
Yeah, that's actually perfect because I've got Discord on my phone too, so I should be all good for answering questions on Discord quickly. Piazza's still great, but I think if you want like quick answers or just like if it's a small question, just go ahead and hit us up on Discord. That works. Sweet. Okay. Cool. So moving on, project schedule. So again, like circumstances have led us to develop a new project schedule. So Ashwath and I talked about that yesterday. I think we're removing one project from the total, just so we can make the workload more manageable for you guys.
I have some dates. I can just read them off. The
Perfect.
extra credit quiz that's currently up is asking about a date, just so I like so pay attention to this, I guess. So your midterm will be the like next Friday, a week from today. You'll get more information about that like this week. It'll probably be released like midnight on Friday and due like midnight on Saturday, so you have a full 24 hours to like scan and submit or something. Or if it's an Elms quiz, we haven't decided that yet. And then after that, it's going to be basically a project a week until the final project where you'll have 2 weeks to do it. And each of these projects are going to be pretty like stripped down just due to time constraints. And like there may be like situations where I'm giving you a template and you'll just have to like finish you'll have to finish the template pretty much. Uh, Rod asked what time is it for ending the exam. So basically like midnight to midnight. So you'll have all of Friday to do it. Yeah. Yeah, so next Friday the 10th. That's what I was thinking anyway, subject to change.
Yep, that should be good. We'll make it like universally available for like the entire 24 hours. Yeah,
Yeah, if you have issues, PM me for sure.
that should be perfect. Should be good for anybody in any time zone. And if anybody's wondering what the midterm will cover, it'll be lectures 1 through 5, or like weeks 1 through 5. Oh, okay, okay.
Yeah, no worries, Rod. We'll work. We'll be flexible.
Yeah, it's a weird time for all of us. Okay, sweet. Cool. Thanks, Ashwath. And then I guess we'll just get like a thing posted on like Piazza or like up here on Discord for the schedule. See what Max is typing.
Oh, true, I forgot to say it. 420, April 20th.
Beautiful. Sweet. Okay. Cool. Yeah. Once again, we'll get some stuff posted for that, so that should be no problem. Yeah. Just keep your eyes on Piazza, and I think we can put stuff on the Discord announcements as well. Awesome. Okay. So that's the changes to the project schedule. Again, it'll be like a lighter load for everybody. So I guess look forward to that. And then new submission guidelines. Again, there's a web app that we now can use to submit our stuff. Since I'm sharing the screen, I think I can go ahead. Can anybody see like a new tab that I create?
Yeah, I can see it.
Oh, sweet. Okay, cool. So then if I go to, Ashwath, do you mind if I just show them real quick?
Yeah, go for it.
Okay, sweet. So all you have to do is go to, I think it's CMSC389E.cs.umd.edu, port 3000. And it's this web app where I don't have like a zip file at the ready right now. I'm on my Windows partition, but all you have to do is make a zip file and put your world file in it, right? And your world file should have the name directory ID dash project number, and the zip file should have the same name, right? So again, we'll post guidelines for submission using the submission app. But if you just type in your directory ID and your password here, and you submit the zip file there, click submit, it should just show up on the submit server in a bit.
Also, one important note is that you need to have the latest version of the mod and run the tests on that latest version of the mod. Otherwise, this won't work. There were a couple people who hadn't done that. So yeah.
Oh, good point. Yes.
No, Fiber Drive asked directory ID meaning UID. No, it's your directory ID, so the letters.
So for me, it would be like for my project 4, it'd be like Aprevine dash 4, or sorry, no, whoops, and not on that field, but yeah, this thing basically. Cool. And then your directory ID password, whatever that is. You click submit, and just like magic, it basically just shows up in the submit server. Cool. Again, we'll help you address any issues with that if you have them. So that is probably how we'll be handling submission for project 4 at this point. So we'll make an update on Piazza. Grades will still probably be on Elms. Cool. Okay, so that's what we've got about the submission guidelines. Now I guess we'll go ahead and get started. So yeah, sweet. Okay, so quick introduction. What is sequential logic? Well, to understand sequential logic, we have to kind of think about combinational logic at first, right? And combinational logic is exactly what we've been doing up until so far, right? Where you have a circuit, you have these defined inputs, but more or less that circuit can be represented by like a static truth table, right? So in other words, if you know the inputs, then you know exactly what the outputs will be, right? So if you know the structure of the circuit, you can decide the outputs in just one like iteration, one calculation. That's what I'm trying to get at here. So yes, I have that little your next line will be down there because you know the inputs, then you certainly know the outputs after just one operation, right? Um, but more often than not, we have to build circuits, right? And we have to represent logic in ways that are far more complex than this, right? So enter sequential logic. That's sort of like the topic of what we're going to talk about today. So what is sequential logic? Well, when it comes to knowing what sequential logic is, I guess the whole point is not knowing in like one cycle, one execution, where your output will be, right? Um, in other words, the circuits that you're building don't just use the initial inputs. They use the outputs of previous iterations of the circuit to decide the output, right? Um, I know it's sort of abstract when I talk about it this way, which is why I think on the next slide, yes, it's not actually that bad, right? We're just doing exactly what this diagram says. We're taking the outputs of your circuit back into our input side for further processing, right? And if you want a programming analogy, which I think would be super helpful since we're all comp sci majors, just think of a loop variable, right? Here we've got iterative um, sequential code where we have my input variable here, right? Set that equal to 0. But then you can see in this loop, you're just changing that input variable, adding 1 over and over as this loop iterates, right? In other words, every time this loop iterates, you want to use the input of the previous, like the input coming from the previous loop iteration. So that's sort of like an example there, right? Every time this block runs, using the previous output of this, like, loop block to sort of keep doing that over and over. So that's what we've got there. That's sort of like a programmatic analogy for this sort of thing. Not like a perfect analogy, but again, sort of like a neat example as how we'd represent that with code. Okay, so that Python segment may have made sense, right? But we're missing a key element to help us translate this into like our digital logic circuits. Specifically, we have no idea how to recurrently store the value of a variable every time our circuit executes. There's a little pun there. We're looping back to the idea of memory, right? So the real key here is to be able to represent the data that you're producing um, from each iteration of your like digital logic circuit and dumping that into some sort of variable or storage so you can use that in the following consecutive iteration of your circuit. So that being said, here's how we'll get that done using memory and latches, right? So the first ever type of memory ever used, right, was chained NOT gates. And again, we're talking about memory because we're thinking about ways to store values um, between iterations of a circuit, right? I think the first thing we should talk about is the first ever type of memory that was used. And it turns out it's just this little construct right here, this little structure. And it looks pretty simple, and that's because it is, right? It's like a fairly stupid memory construction. Think about it. Let's assume some initial states. Let's assume in is 0 and out is 0, right? Um, Fine, that's great. Um, we'll assume that out is our representation of whatever is in memory, and in is how we'll be feeding data into that memory. So if in is 0 and out is 0, that's fine. That means that there's nothing stored in memory. But if we go ahead and send like a one signal very quickly through in, what will happen is you get inverted knots here, and then you'll have sort of like a short circuit, right? That in signal will continue looping and traveling, right? And leading to the out. So even if you turn off this input, you'll still have that one sort of going in a circle, which is a sort of strange thing to think about. But long story short, that out will stay on forever, right? No matter what, you'll find that the output stays at 0 um, until the input becomes a 1. Then, no matter what we change the input back to, the output will still stay at 1. So keep track of something, right? In other words, we can go ahead and turn this little switch on, but we're not actually able to turn it back off, which is kind of a humongous systematic flaw in our memory design. But at least we got halfway there, right? Now we can set a memory to like on. We have no idea how to turn it off, but now we can do at least half of that. Does anybody have any questions about this basic one? Yeah, JoJo reference. Yes, okay, cool. Anybody have any questions at all about the first ever memory? By the way, if I don't see any messages, then I'll just continue moving forward here. Cool. Actually, why don't I go ahead and I'll answer the questions, um, like the text one. Cool. Okay. Okay. I'll just go ahead and like dump answers there as well, just in case people see people want to look at this later. But yes. Okay. So if I don't see any questions, I'm just gonna go ahead and continue moving forward, and that'll be how we do this. Okay. Cool. Awesome. So this is our first step for figuring out memory, right? And now we want to figure out a way to set that back to 0. That's essentially what the key is here, right? Found a way to set something to 1. We have no idea how to reset it. Well, that's where this construct called the latch comes in, right? We want to do more than just set the value of memory just once. You could say, in other words, that we want to be able to reset memory, right? So I invite you to think for a moment. How can we augment the previous example? How can we do something to that circuit, this circuit that we have here, um, to allow us to reset the state of our memory? Um, Unfortunately, it's not like a one-off simple solution. It's kind of like a little bit complicated, but we'll explore it. We'll walk through it together. And again, it takes advantage of this little. I feel like the hardest part to understand here is this little bit here, where we have, even though this input is turned off, we now have this short circuit going on here, right? It continues in a circle. Um, and again, these NOT gates, they serve as diodes, right? They keep current flowing in one direction. So that's just like a little key there. That's the hardware reason that we have two NOT gates and not just a simple loop that goes like that, right? Um, okay. So that being said, let's talk about how we can use that. We can take advantage of that whole short circuit infinite loop business to make us a sort of latch, something that goes from one state to another state and the other state back to the first state, right? Um, so you can perform this with a commonly known circuit, a commonly used circuit known as a latch. And there are a few ways to build this latch, right? And essentially, what a latch is a circuit where you can have an output producing one signal. You give it a certain pulse, and it flips over to the other signal. You give it another pulse again, and it flips over to your initial signal again. So essentially, it's a circuit that provides two states, right? And this will make a lot more sense when we actually look at the diagram. But as it happens, there are a few ways to build something like that. And in this class, we've decided that we'll probably only work through one, right? Just because conceptually, I feel like that's the easiest way to sort of approach this. If you want to learn more about latches, I'm probably going to post some supplementary material on extra types of latches and things under week 8 on the course website. Again, just expect that by end of day today. Okay, so let's take a look at the NOR SR latch, right? And there are, like I said, many types of latches. We're just going to look at sort of one conceptually today, just to sort of make it easier on us when we figure this stuff out. But again, a few other latch designs, you can look at them on your own time if you'd like. Cool. Okay. So this is a NOR SR latch. It looks a little fancy. And that's because, again, you can see some infinite loop business going on here. We're sort of taking advantage of that. Here, the infinite loop is a little less obvious, but you have like the output here goes down, comes into the input here. The output that this produces goes down and comes into the input here, and you get like a nice little cycle, right? Um, but don't let it fool you. This is basically a circuit that switches between two output states, right? Because essentially what we're trying to get here is having Q on and Q bar off, and then if you give it the right pulse, it'll flip. It'll say, okay, now I'm turning Q off and I'm turning Q bar on, right? And so you can see here this little sort of truth table, right? Is
Aki,
basically.
you're a little bit quiet. Is there a
Oh,
way
am I
for you
quiet?
to increase your mic volume a little bit?
I thought. Oh, here, hang on. Does that do anything?
You might be able to lower your mic threshold.
Oh yeah, I'll probably go ahead and do that. You know what's probably happening? It's probably taking my computer audio and not the mic that I'm using.
Oh shit.
That's a pain. Well, okay, let's see. Um, oh, I see what's going on. Um, does that do anything?
No, it sounds the same.
Huh, okay. I have an idea. I'm gonna hold my computer closer. Does that help?
Not really.
Shit.
Try to say something?
Uh, yo.
It's doable, I guess. Just like everyone, you can turn them up individually on Discord, I suppose.
Oh, okay, cool. My input volume's already at like 100.
I just made you 200%, and I can hear you a lot better. So
Oh, okay, cool. Yep, I guess that's the solution. My bad. Okay, cool. I'll figure that out by next time. Probably just like a driver's issue. Okay.
all right, yeah. Sorry to interrupt you.
No worries. Cool. Okay. So yes, basically a circuit that switches between two output states, depending on which of its two inputs is the signal coming through, right? And if we think about it, right now the circuit's in a certain state, right? In other words, by default, this starts off with a state, and I'll go ahead and talk about that a little later. But what we're trying to say here is that given an input coming in of 1, 0, right, um, through the 1 through the S, then you'll turn Q on, right? And then, no matter what happens, if you stop giving inputs at all, Q will still be on. And then let's say you give it an input through R, then Q will be off and Q bar will be on, right? So that's sort of like setting and resetting. And I guess a really easy way to look at this would be the example that I've got coming up. But basically it's just that, right? The circuit is designed such that if you feed in a pulse from S, then Q is going to turn on if it isn't on already. And if you feed in a pulse from R, then the circuit is going to flip. It's going to turn Q off, and then that signal is going to propagate through here and turn Q bar off. And no worries, I've got like an actual example where we walk through this because it's probably a little confusing. But while we do this, I suggest you keep the NOR truth table in mind, right? That's probably the easiest way to think about going about all this. Okay, so note that one more thing. The input of 1, 1 will result in undefined behavior, and I leave that as an exercise to the viewer, but you'll quickly realize that giving it 1 and 1 at the same time will just screw it up royally. So that's the rule here. We don't want to be giving a latch 1 and 1 as an input. In other words, I think for like official truth tables online, it literally says undefined. So yes, that's the little fun fact there. But we always want to be giving one input at a time. Okay, and again, this next example that I'm going to walk through is from this guy on YouTube called Ben Eater. I used his videos last year to figure out some stuff, and I used his videos to learn some stuff for 216. He's a great person to look to explaining some of this like systems level stuff and digital logic stuff. So I'll go ahead and link his SR Latch video in the on the course website with the appropriate actually we'll just link the whole video. It's got some good background as well. But yes, so look out for that. But I'll be going ahead and going through his example of an SR latch because I think it's pretty fantastic. Okay, so let's start off with a diagram of how the circuit looks by default. We'll notice that the circuit's a little weird looking. So let's analyze how the signals actually travel through the whole thing, right? And again, just like we talked about, we have the potential for infinite looping here, right? So you want to take care not to give it 1 and 1 at the same time because that would end in a disaster. So below, you'll see the circuit as it stabilizes with an input of the default, R equals 0 and S equals 0, right? That's pretty important stuff. If we give the circuit nothing at all, this is how it's going to stabilize in the first place, right? Again, NOR is just the opposite, the logical complement of OR, right? So keep that truth table in mind. So these are the results that will be produced if, we give it nothing at all on the inside. This is how it's going to be set up at first. Q is going to be on, and Q bar is going to be off. Now that's fine. This is great. We're totally fine with this, right? Because our circuit is currently in a certain state, right? And in this case, we can call it the 1 state. That's the sort of convention here, right? S stands for set, and R stands for reset. And again, I'm starting it off in this state, but obviously it goes without saying that you can start off your circuit in any state. You can have it with Q bar on and Q off as well if you'd like. I'm just going to walk through how we'd flip from one state to the other, but keep in mind that the flip can happen from both sides. It's just the mirror image of what I'm walking you through right now. Okay, that being said, let's assume that in this current state, we're providing nothing from the inputs, but the circuit is, configured or like it's set in such a way that Q is on and Q bar is off, right? Now the next thing we'd do is we'd provide an input somewhere. Right now, since we're in the quote-unquote set state, we'd go ahead and transfer it to the reset state. And the way we do that is we'd provide this first step here, where we have, now that we sent a 1 through the reset state, great, that's where we're sort of sort of starting off here, right? So this is the only change made in this slide. I'm trying to go step by step here so we can walk our way through the actual execution of the logic. But yes, we'll see how the resulting value goes from only Q being on to only Q bar being on. So again, here's the first step we've got. 1 is coming through R, right? And then you'll see that that propagates forward, right? Now that 1 is coming through, our NOR gate is going to be producing a 0, right? That's because, again, it's the opposite of OR. So then this 0 comes down and propagates down to the other NOR gate, right? Which is great. But then we'll see that now that 2 zeros are coming into this NOR gate, we've got a different situation going on, right? This NOR gate will now be producing um, um, this this bit right here, right? This 1. And you can see that now that this 1 is coming out of this NOR gate, don't let it confuse you. The current is flowing out from here, but it'll also doubly be flowing, coming down to this NOR gate as well. And why we do that is to allow for us to, here, hopefully I have like a, yeah, here we go, this bit right here. We move it back to, well, I'll get to that later, but yes, this is the final step. And now you see the Q bar is on, and finally, right, we have this coming out down here and feeding into the previous NOR gate. And the reason we have this little wire in the middle here to take care of this extra feed in for the circuit is such that we can now have our circuit stabilize in this state, right? And you'll see that we've got some familiar situation going on here. This is, in fact, the exact, like the basic complement of what we had up here. The perfect opposite, right? In this case, we have zeros as inputs again, but in this case, the circuit has stabilized and is producing Q bar as an output and not Q. And the way we accomplish this is by simply sending a singular pulse through the R flag, the R input right there. So that's the beauty of latches, right? They can keep a state for us, they can keep track of a state for us without having to keep a signal coming in consistently, right? And circuits like this, where you don't require a consistent input and you can store some form of output, right, are the basis for building structures in sequential logic, right? So I'm going to pause right here. Does anybody have any questions about that so far? Give you like a little bit to ask questions, and if not, then we can continue moving forward. But that's really the basis for this logic here, right? And I know this gets into sort of abstract or like digital logic-y stuff, so try to tie that in back to Minecraft a little bit. I think I've got some examples below, but stay tuned for that one. But yes, okay. So now we've figured out latches. We've got this stuff sort of more or less, understood. I'd say again, this is the simplest example of a latch. There are other latches that I'll be linking on the course website. But I'd say if you want to understand this concept, go ahead and you can look at these slides again, or you can watch this video that I'll post. It's only like 10 minutes long, and it's pretty helpful. I'd say if you watch that, you'd definitely understand, how latches do their thing. I think the guy in the video has like a literal hardware example that he shows off while he walks us through this. Okay, so that being said, let's move on. You can make, it's notable that you can make an equivalent latch to the NOR SR latch by using NAND gates, right? It's basically functionally the same as the NOR SR latch. Additionally, there are other types of latches. Like I said, since this is a 1-credit latch, this is the one type of latch of that 1-credit class. This is the one type of latch that we'll be going over in depth. But again, we'll be posting some more stuff about the other types of latches, so feel free to check them out. Cool. So we'll be moving over to flip-flops and clocks now, but don't let the new terminology confuse you because flip-flops are basically just latches with an extra step, right? So let's talk about why you'd want a flip-flop, right? And there's certainly not like that's just a little joke there, just to lighten the mood, if you will. But in just one sentence, flip-flops are basically just latches, which are only usable when you give a control input. When a control input is on, so a little typo there. That may sound a little weird, like a little unnecessary, but it really helps when we want to update memory at certain times, right? In other words, this goes hand in hand with a clock. So let's talk about that. Let's say you wanted your latches to update, but only when you were certain that the inputs for your latches were for sure decided, right? Using a flip-flop instead of your latches will only allow the latches to change when that control input switches to on, right? Because think about it, there's a sort of delay between when you send that one input signal, right, from the S or the R input, and to when the latch will actually flip over to producing its corresponding Q or Q bar value, right? So we're basically just saying, okay, I want you to tell me what the memory value is, but I only want you to tell me it after you figured your shit out, after you've decided, right? Um, and it's really important to keep time when you're making these sequential circuits, right? Because again, you're not deciding everything when the program starts. You want to make sure that you keep it to a sort of schedule so that the right things flip, or like the right circuit bits go off at the right time. Otherwise, if you really wanted to figure out how to delay stuff, right, I would imagine you have some ridiculous network of repeaters that slow down some signals and speed up other signals to make sure that everything runs at the right time. You'll find that when you're building more complicated circuits, relying on a system like that is completely like abhorrent. It's terrible and disorganized, which is why the advent of the I guess the processor clock came around, right? It would let us sort of time the quote unquote flip flopping of um, different parts of our circuit so that we could make sure that everything runs exactly as it's supposed to. And if you're having trouble again, like thinking of why this would be necessary, there's a reason we set our test delays to 2+ seconds instead of having them run with no delay. We literally are waiting for the circuit to finish executing, right? Of course, in real life, that's like microseconds based on whatever, like how architecture works. In Minecraft, we have a cooler representation of how this could possibly be useful, which is why Minecraft is my favorite game for learning about things like this. But yes, think about that analogy if you want to sort of, I guess, understand how that would be applicable. Um, but yeah, so we'll talk about how we'll actually make one of these, right? So let's take a look at the plain old latch. This is what we've got. Again, this is just what we talked about right now. We've got it in Q bar state, right? And a flip-flop is really just a latch with a simple extra step, right? Just like that. Don't let it confuse you. All we've done is we've added these little AND gates right here at the top left and the bottom left, right? And the reason we have these AND gates is you'll notice that we're not able to send a pulse through any one of these, right? Unless that control wire is on. In other words, your memory won't flip and it won't flop unless you've got that input being on, right? And usually that input is handled by a clock, right? Because what that clock will do is at some set amount of time, it'll send a signal down the control wire, right? And then once it does, that control wire will suddenly be on for like, I don't know, 1 second, right? And then when it's on for that 1 second, whatever signal is coming in from S or R will say, oh yes, it's go time, and it'll propagate down into this actual latch, right? But if that control signal isn't on, then no signals will be allowed to travel through to this latch. So it will not change state unless we are telling it to change state, right? And that is huge. That is exactly what we want in a case like this, right? Again, we want to make sure that we're changing and accessing this memory only when we really only when we say it's okay to. In other words, we're sort of enforcing when our memory changes state, which is far more useful than you may initially think, right? Next, you want to make sure that this input from this control wire is handled in an appropriate way, right? So we've got this control wire, but then you might ask, okay, well, how do we get this like routine pulse coming out of the control wire? Well, that is handled by a clock, and that is like our next slide. But first, we'll talk a little bit about this. There are plenty of ways to make flip-flops in Minecraft, right? Keep in mind that there are like a few variants of flip-flops, because since there are a few variants of latches, obviously there will be a few variants of flip-flops, right? But Minecraft has this amazing feature known as locking redstone repeaters, and we've got probably put out like a video on like latches specifically or flip-flops. But we can leverage that feature, right? Basically, if you feed in a current from the side of a Minecraft redstone repeater, and I would encourage you to like Google Minecraft locking redstone repeaters if you haven't already. It's like integral to the sort of digital logic stuff. But if you feed in a current to the side of a redstone repeater while it's got current flowing through it, you can kind of lock it, right? You can make sure that whatever input's coming out of that repeater will now be coming out of it no matter what the actual input to that repeater will be. So if it's producing like an on signal out and you send in a current from the side, then that repeater will be locked. No matter what comes into the repeater from the actual input after that, it'll still be producing an on signal. Again, it's a little interesting to sort of look at. I've got this YouTube video from this guy here. Oh shit. Okay, well I guess video unavailable. Well, I'll fix that. Um, but
that is essentially, well, there's like a really quick, what I'm trying to say is there's a really quick and easy way to build flip-flops in Minecraft, right? So we'll have some stuff on the course website soon, and I'll fix that link. But a great way to get started is to look up Minecraft Latch or flip-flop with locking repeater. Um, and one little word of precaution when you do this project, actually, you probably don't want to be using the piston-based variants of these like flip-flops for two reasons. Number one, it's a little harder to understand, right? Um, Using pistons is not a very orthodox way of representing circuits, and you'll find that most piston-based sort of networks are delay based, right? And we don't want that. The Redstone mod that we have is configured to produce signals in such a way that there's no delay there. Repeaters have no delay. When you use constructs like pistons, you are building in Minecraft's built-in delay, right? It takes a certain amount of time for a piston to fire. So really, at least for this class, I'd say it's bad practice to be using pistons in your designs. And even if you do, like, the more pistons you use, the more like potentially screwed up your project's going to be, right? At the end of the day, that could probably be something as simple as just setting your test value to like 10 seconds when you execute, right? Um, but it could also cause some like synchronous problems that you probably really don't want to be dealing with. So again, when you make these latches and flip-flops, you're going to see a lot of online designs that say, oh yeah, you can use a door or like a minecart or piston to get this done. But I implore you to go ahead and use repeaters and comparators if you really want to, just because those basic redstone constructs are the easiest and most conventional way to work with the stuff that we've provided you in the mod. So, little word of caution there. Don't use pistons. Probably a bad idea in this class. If you're building like secret doors or whatever on your server, feel free. But in this particular class, for the sake of your test and everything coming out properly, um, go ahead and try to stay away from those. But yes, that's my little spiel on pistons and stuff. But again, locking redstone repeaters is the key there. So we'll probably post some stuff on that to help you figure it out. Okay, so that being said, finally, we'll be feeding into that control wire. So we had the little aside on flip-flops, right? But this control wire here still needs a valid input, right? We be able to give it the right thing such that we can activate our flip-flop at the right time. And the way we manage that is a clock, right? We need to provide a steady cycle for our circuit to periodically update memory. And simply speaking, clocks are the way to do that. And clocks are actually like the simplest circuit. I think that's like one of our projects that we're mooshing into another project just because all you have to do is make a circuit that produces a 1, then a 0, then a 1, then a 0 on a set timing scheme, right? Now, if we gave you this assignment to do in real life, you'd be kind of high and dry. Um, a long time ago, I think the first clocks that they used were literal like quartz crystals. They'd pulse like a current into it and then use the vibrations to create like a reliable clock, right? That's why on your watch, you see some people have watches that say like quartz crystal, right? That is the first programmatical clock. They're basically just running a current from a battery into a quartz crystal and then using the vibrations there to accurately keep track of time, right? So now people have stuff like atomic clocks and things like that, but quartz crystals were the way to go back in the day. But luckily, we're just kids playing Minecraft, so Mojang has made clocks very easy for us, right? I've included this picture here. It's a little outdated, right? This one just uses repeated NOT gates to sort of slow down a signal, but now all we can do is set some repeaters in a circle in this like same configuration, right? And you'll literally see, like if you do that, you'll have a redstone current starting like here, and you can visually see it travel around in this circle and come back and activate whatever is here at this pink wall block, right? And it's way more intuitive than you might think. You can literally see the signal moving around, and if you wanted to speed up or slow down the signal, all you'd have to do is change the configuration on your repeaters, or you could just make that circuit bigger, right? The longer that that signal has to travel, the longer it'll take to come around in a circle. So you can actually, number one, you can slow down servers hugely by doing this. If you have a bunch of clocks and loaded chunks, um, sending redstone signals around, doing whatever, like turning lights on and off, you could have a fantastic strobe light show and also slow it down. So it's a little word of caution there. But this is how you want to be accomplishing building that clock here. Um, so in coming projects, you'll be building like sort of uh, properly built latches that'll be active when you decide them to be active. So again, like sort of flip-flops, right? And you'll also be implementing a clock, right? And again, we will post stuff about that to make it easier. But I would say the two main takeaways here are that we need a way to store memory, right, as our program sort of executes, which is solid. The way we do that is using a flip-flop, right, which is essentially just a latch that has an added interface to let it work nicely with a clock. And of course, we need a clock to make sure we're setting that memory and accessing that memory on time. So those are the two real keys there that we'll be sort of moving forward with in terms of concepts. And again, supplementary material will be posted on the course website. And that's all I've got for lecture. In particular, does anybody have any questions about this? Fantastic. Cool stuff. Well, you're welcome to hit us up at any time with questions about this stuff. But I think that is what we've got for today. Again, if people have joined and they haven't, I guess if you joined late, you missed the first party announcements. Ashwat has made a pretty fantastic web app to submit your projects, right, via zip file. I'll probably go ahead and link that at the top of the course website as well, just so it's easily accessible. But it should be available here on Discord, on Elms, on Piazza, and the course website. And again, I made a Piazza post as well, which aggregates all of our online resources, just so you have like one place to look to like see, you know, which things you should be checking for what. Because I know with plenty of classes and people using different platforms, it might get a little confusing. This class is not supposed to be hard for you guys, so we are making stuff like a little easier since we're all online. And again, I've gotten a few emails about special circumstances. We can go ahead and work through that. And if you have really extenuating circumstances, we can go ahead and talk to Alex, who's the facilitator for this class, and we can move forward with things like perhaps like grading or stuff like that. So yes, that's all I've got to say. Ashwat, did you have anything you wanted to add?
Nope. Just yeah, get those project fours in. I'll pretty much be staring at the logs for the next like 24 hours. So if you like submit and it doesn't work, just PM me because I'll be able to see what went wrong and I'll be able to tell you how to fix it. Yeah, I think as of right now, like 10 people have submitted, which is good. But we need more. So
Sweet, awesome. Yep,
yeah.
that's perfect. All right. I guess that is it for lecture. I'm gonna go ahead and like start saving and like uploading this stream stuff. But feel free to stick around and ask questions if you have any. I'll probably be hanging out here for like a little bit. But yes, thank you for coming and attending our class on Discord. This is quite solid.
All right. Later, guys.